Alright, in this video we're going to look at a couple of additional formulas for trig. So we're going to look at the double angle formulas, and the first one is sine of 2a is equal to 2 cosine a sine a, and we get that from something that we had before when we had a sine of a sum of angles. The sine of a plus b is equal to sine of a cosine b plus sine of b cosine a. So if we just choose both the a and b to be a, so sine of a plus a is equal to sine of a cosine a plus sine of a cosine a. So they're the same thing, so there's two of them. So sine of 2 sine of 2 sine of a cosine a. So that's kind of an idea where that one comes from. Similarly, we can use those formulas for the sum of cosines to find a sum of an angle of cosines to find that formula, cosine squared a minus sine squared a for that cosine of 2a, and then using a Pythagorean theorem that can be rewritten as 2 cosine squared a minus 1 and 1 minus 2 sine squared of a. And we could probably come up with something similar for the tangent of 2a formula, which is 2 tan a over 1 minus tangent squared a. So we're going to go through a couple of examples of just applying this. It's helpful. It has some instances in solving trig equations, and there's some instances in calculus where it might be helpful too, where we need to do some factoring. Okay. So we're going to be given that the sine of x is 3/5 and the cosine is negative, and so that was going to place us in quadrant 2, and what we want to find is sine of 2x, cosine of 2x, and tangent of 2x. Okay, so we're in quadrant 2. We'll draw in our reference triangle, so it's a 3, 4, 5 90-degree right triangle, so we can find that missing side is going to be 4 using Pythagorean theorem, because we're in quadrant 2 and that's along the x-axis. That's going to be minus 4. Okay, so sine of 2x is going to be 2 sine x cosine x, and so the sine is going to be 3/5, opposite over hypotenuse, and the adjacent side is negative 4 over 5 for the cosine. And multiply that all together, it's going to be negative 24 over 25. So if we doubled an angle in quadrant 2, if you're in quadrant 2, that means your pi over 2 and then x and then pi. So then if we double that, that's pi 2x and 2 pi. So that's going to be in the lower half of the unit circle. So the sign is certainly negative in those two quadrants 3 and 4. The cosine and tangent may be positive, negative, it just depends. So at least one of them is going to be positive because they're not both positive in quadrants 3 and 4 together. Alright, so let's try the cosine. So the cosine of 2x is going to be cosine squared x minus sine squared x. And the cosine will be negative 4 over 5 squared minus the sine squared, 3/5 squared. That's going to be 16 over 16 over 25 minus 9 over 25 should give us 7 over 25. And then the tangent of 2x is going to be 2 tangent x divided by 1 minus tangent squared of x. Tangent's going to be 3 over negative 4, or negative 3/4. Okay, let's go ahead and work that out. Okay, that's going to be negative 3/2 divided by 7 over 16. So we get negative 24 over 7, so that makes sense. So the sine is negative, and the tangent is negative, and the cosine is positive. So that means that double angle happens to be in quadrant 4 according to this. Okay. Alright, let's try another one. So this time we'd like to find the tangent of 2x, or 2 theta, given cosine of theta is equal to 3/5, and theta is in 0 to pi over 2, so it's in that first quadrant. Okay, so if it's in that first quadrant, we've got 0 less than theta less than pi over 2, and if we double everything, it's going to be 0 less than 2 theta less than pi. So it's going to tell us it's going to be in quadrant 1 or 2, so the tangent could be positive or negative of this 2 theta. It just depends on how big of an angle theta is. Okay, so we'll draw a reference triangle adjacent over hypotenuse, which would be the 3/5, and then using the Pythagorean theorem we could find the missing side is 4. Okay, alright, so tangent of 2 theta is going to be 2 tangent of theta divided by 1 minus tangent squared. So that's going to be 2 times opposite is 4 over 3, and then 1 minus 4 over 3 squared. Okay, so upstairs is going to be 8/3. Downstairs, when we're all done, it's going to be negative 7/9, and then we can go ahead and flip and multiply and reduce, and we get negative 24 over 7, which tells us that this angle ended up being in quadrant 2. Okay, so that is the double angle formulas. We're going to look at some other formulas here in just a second here. So let's put up some power reducing formulas. Are real helpful, especially when we want to do some integration in calculus. We want to reduce some powers. So I'm just going to do one example, but here we'll give you the formula. So sine squared is equal to 1 minus cosine 2x over 2. Cosine squared is going to be equal to 1 plus cosine of 2x over 2. And then the tangent squared of x is going to be 1 minus cosine x over 1 plus cosine x. And forgive me, I had an error with my tangent squared. It should be 1 minus cosine 2x over 1 plus cosine 2x, because the tangent squared is just going to be sine squared over cosine squared. So then you would just have the sine over the cosine, and after we flip, the 2's would absorb. So where we would get this sine squared power reducing formula is it comes from the double angle formula for the cosine, and then we would just solve for sine squared in that particular instance. That being the 1 minus 2 sine squared x, that was equal to cosine of 2x. So we go ahead and we just solve for this part here, and the minus 2 sine squared, we'll solve for that sine squared, and that'll give us that power reducing formula there. So let's go ahead and reduce sine x to the 4th power. So sine squared is 1 minus cosine 2x over 2, quantity squared. So we got 2 of those, so what we'll do is we'll go ahead and FOIL that out. So the 1/2 times 1/2 is 1/4, and then 1 minus 2 cosine 2x plus cosine squared of 2x. And then we get to do the power reducing formula for cosine squared of 2x. So then where the 2x is in the argument, that'll become a 4x, because it's just double that angle there. So it's going to be 1/4 1 minus 2 cosine of 2x plus 1 plus cosine, not 2x, but 2 times the angle, so 4x, all over 2. And what we'll do is we'll go ahead and clear this fraction out a little bit by moving this 2 out here, and that's going to make it an 1/8. If I do that, I am going to need to compensate by multiplying this by 2 and multiplying that by 2, so that'll be a 4. Then you'll have 1 plus 2, which will be 3. So it's going to be 1/4, I'm sorry, not 1/4, 1/8, and then 3 minus 4 cosine 2x, and then plus cosine of 4x. And that's something that later in calculus that'll be a lot easier to integrate than the sine of 4x, because we'd be kind of stuck with it there. So this makes that a lot nicer. All right, well, let's move along, and then we have some more formulas. We got the half angle formulas. So where we can get these half angle formulas is doing some manipulation of the power reducing formulas. So for example, if we write sine sine squared of x over 2, that's going to be equal to 1 minus cosine 2, and then x over 2 all over 2. So then we have sine squared x over 2 is equal to 1 minus cosine x over 2. And then what's going to happen is we're going to go ahead and take the square root, and when we solve with equations and we take the square root, we're going to get plus or minus. So that plus or minus is going to be dependent on what quadrant x over 2 is going to be. I think we'll use our book's notation, and they use the letter u instead of the letter x. It doesn't matter, it's just a dummy variable. So half angle formulas. Sine of an angle u over 2 is going to be plus or minus square root 1 minus cosine u all over 2. Cosine of u over 2 is going to be plus or minus square root 1 plus cosine u all over 2. And then the tangent squared u, tangent of u over 2 is going to be 1 minus cosine u over sine u, or sine of u over 1 plus cosine of u. And depending on if we want to multiply it by a conjugate there, we can have either form there. Okay, so we can use this to find, for instance, the sine of 75 degrees. Well, that's the same thing as 150 over 2, so we can get the same form. Now, 75 degrees is going to be in quadrant 1, isn't it? So in quadrant 1, the sign is going to be positive. So when we go through and do this, we will not put the minus. We'll just assume that it's the positive one. So we got 1 minus cosine 150 all over 2. Take the square root of that, and it's going to give us not degrees there, just 0.96 as the ratio of the sides of the triangle there. Okay. Now let's look at the cosine of 3 pi over 8. So 3 pi over 8, that's going to be in quadrant 1 also. 3/8 is less than a half, so that's smaller than pi over 2. So the cosine will be positive. And what we'll do is we'll rewrite this as cosine of 3 pi over 4 divided by 2. And that's going to be 1 plus cosine of 3 pi over 4 all over 2, and then we'll take the square root of that, and that's going to be approximately 0.38. And just for good measure, let's go ahead and try one more. Let's say we want to look at the tangent of 75 degrees. So everybody, all three of these angles are in the first quadrant, so the tangent will also be positive here. So we'll write this tangent of 150 degrees all over 2. And I'll use the sign on top, so sine of 150 divided by 1 plus cosine of 150. Okay, so plug that all into your calculator. Then we get about 3.7, and again, this is not degrees. It's just a ratio of sides of a triangle. Well, then just be careful that when it's in degrees, you're using degrees in your calculators. When it's in radians, you're using radians in your calculator. Okay, let's look at a little bit more, some more applications here. So let's say that we're given that the cosine of theta is negative 12 over 13, and theta is going to be in quadrant 2, which means it's going to be between pi over 2 and pi. Okay, and so then if we look at the half angle, we would just divide that by 2. So pi over 2 divided by 2 will be pi over 4. And then the pi will become pi over 2. So that's going to tell us that we're in quadrant 1. So since we're in quadrant 1, that means when we're doing the sine and the cosine half angle formulas, we'll go with the plus. So it'll be square root plus 1 minus cosine u over 2, 1 plus cosine u over 2, depending on if you're using the sine or the cosine. Alright, so sine of theta over 2. I'm going to go ahead and draw my reference triangle. Again, so the reference triangle lives in quadrant 2, and it's a 5, 12, 13 Pythagorean triple. So 13 squared is 169, 12 squared is 144, so 169 minus 144 will be 25, and that'll give us that other side of being 5. Alright, so the sine of theta over 2 is going to be 1 minus cosine of theta over 2, all under the square root. So it's going to be 1 minus negative 12 over 13, all over 5, all over 2. And that's going to give us about 0.98 for that ratio of sides. So what that tells me is the sine of pi over 2 is 1. This tells me that we're pretty close to pi over 2 here with this triangle here. So cosine of theta over 2 is going to be 1 plus cosine of theta over 2, and then all that under the square root. So it's going to be 1 plus negative 12 over 13, all over 2. Take that square root, and that's going to be approximately 0.2. So that's getting closer to 0 for the cosine, so this makes sense also. Now we'll take a look at the tangent, just so we can say we've done the tangent formula also. Okay, so it's going to be sine of theta over 1 plus cosine of theta. It's going to be 5 over 13 divided by 1 plus negative 12 over 13. Multiply the top and bottom by 13, so that's going to be 5 divided by 13 minus 12. So the tangent will in fact be 5 in this case. Alright, well, there are a couple other formulas there, so maybe we'll end up making another video, but this was definitely want to practice these as you're going along.